Welcome back to STS. In today's video, we're going to look at the derivative using the power rule, which is basically a shortcut from having to use the difference quotient. Alright, simply stated, if you have a function f of x where it's equal to x raised to some power, to find the derivative, which is known as f prime of x, you take the power, and that power is brought down to the front as a coefficient, so that n is brought down, and that n will be multiplied by whatever the current coefficient is of x. In this case, that coefficient is 1, times the value or times the quantity x raised to the n minus 1 power. And that can more clearly be stated as just n times x raised to the n minus 1. Alright, let's take a look at a easy example to start. Let's say that we have f of x is equal to x raised to the first power. Well, to find the derivative, that means we're going to pull this 1 down to the front, and then x is going to be raised to the 1 minus 1 power. The next step would be 1 times x raised to the 0, and we know that x raised to the 0 is the same thing as 1, so the derivative is just going to be 1. So f prime of x in this case would be 1. And now let's go ahead and take a look at solving this using the difference quotient. So that'd be f prime of x is equal to f of x minus h, f of x plus h minus f of x, where all that is over h. And remember that we have here the limit as h approaches 0. Well, the function where the new input is x plus h, this turns into just x plus h minus the original function, which is just x, and all of this is divided by h. And again, we have the limit as h approaches 0. As we begin to simplify, we see that I have a positive x and a negative x. Those cancel out, so I'm left with h divided by h. And to further simplify, h divided by h is 1. And when I take the limit of a constant, the limit is whatever that constant is, and we see that those two match. Alright, let's take a look at something a little more complicated. Now let's look at, let's say the function now, let's call it g of x is equal to x squared. Again, we're going to follow the shorthand method, where that means I'm going to take the power, bring that out to the front, times x, and I'm going to raise this to the 2 minus 1. So here I have 2 times x raised to the first power, or just 2x. And again, I'm going to look at this using the difference quotient. Here, let's say g of x plus h minus g of x, where all of that is divided by h. Again, I'm going to input x plus h everywhere I see an x in my original function. So this turns into x plus h squared minus the original function, which is x squared. And again, I keep forgetting leaving this off. That's the limit as h approaches 0. Again, the limit as h approaches 0. So here the limit as h approaches 0, and all that's divided by h. What I need to do now is to FOIL this out. So this turns out to be x plus h times x plus h minus x squared, where all that's divided by h. And again, it's the limit as h approaches 0. When I FOIL, this turns into x squared plus 2xh plus h squared minus x squared, where all of this is divided by h. As we begin to simplify, I say I have a positive x squared and a negative x squared, so those there cancel. Again, I have the limit as h approaches 0. Here I see that I can factor out a h in my numerator, so I'm left with 2x plus h, where the quantity h is on the outside, and I'm still dividing everything by h. At this point, these two h's canceled, and I'm left with the limit as h approaches 0 of 2x plus h. At this point, I can substitute in a 0 for h, so I have 2x plus 0, which is just 2x. And again, we see that there does match what I have here at the beginning. And let's just do one more example. And let's go and just switch to a different color. In this example, let's do h of x. And I'm going to say h of x is equal to x to the third. And again, following the shortcut method, h prime of x, I take the power, bring that out front, and then I decrement that power by 1. So this is going to be 3 minus 1, which turns into 3 times x squared. And let's go ahead and do the difference quotient one more time to show that these do come out to be the same answer. So here let's do h prime of x is equal to h of x plus h minus the original function h of x, where everything is divided by h. Probably should have used a different variable than h, but we'll just continue. I've got the limit as h approaches 0. Here I have x plus h raised to the third power minus the original function, which is x to the third, where all this is divided by h. Now I have to do some FOIL here. This is x plus h times x plus h times x plus h minus the original function. Again, all this divided by h. Again, the limit as h approaches 0. I'm going to multiply these first two quantities together, where I get x squared x squared plus 2xh plus h squared. And I still have to multiply it by this last quantity. I'll do that in the next step. Everything else is just being rewritten. Again, the limit as h approaches 0. Now I'm going to distribute this x to each term. So this here becomes x to the third plus 2x squared h plus x h squared. Now I have to distribute an h to each term. So that's going to be plus x squared h plus 2x h squared plus h to the third minus x cubed. And again, all this here is divided by h. Let's clean this up some. I've got a positive x to the third and a minus x to the third. Let's see, what else can I do here? I've got an x squared h here and an x squared h there. So those become, I've got 2 here and 1 there. So that becomes 3. Let's just rewrite the limit as h approaches 0. So now I have 3x squared h. So that's this term and this term. The rest of these, let's see, what else can I do here? xh squared. Alright, I have another xh squared, so I've got plus, and that's going to be 3xh squared. So that's this term and this term, and I'm left with a positive h to the third, where all this here is divided by h. Scroll down a bit. Alright, so here the limit as h approaches 0. Well, I see that I have a h term that I can factor out. So let's factor out the h. So I've got 3x squared plus 3xh plus h squared, where all of this here is divided by h. As I simplify, these two h's cancel, and I'm left with the limit as h approaches 0 of 3x squared plus 3x h plus h squared. And now at this point I can substitute in the value of 0 for these h's. So I have 3x squared plus 3x times 0 plus 0 squared. So that gives me 3x squared plus 0 plus 0, which leaves me with just 3x squared. And as I scroll back up, you see that the shortcut method also gave me the 3x squared. Alright, so that sums it up for this video, where we chose to use the power rule to shorten up our work. We don't have to go through all these transformations by using the difference quotient. Please subscribe to our YouTube channel so that you can see all of our new videos and catch any updates. And as always, thank you for watching.